In this video, we will do some examples of arithmetic progression. So our first example is find the sum of 11 terms of an AP whose middle term is 30. So here we know that the value of n is 11 and we have to find the S11, that is 11th term. So it is given that the middle term is 30. If we write our arithmetic progression, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. As it is mentioned that there are 11 terms. So here the middle term is 6 because the first 5 terms are these and the last 5 terms are these. So our middle term is 6. As the middle term is equal to 30, so A6, which is the sixth term, is equal to 30, which is our middle term. So as we know, the formula for nth term is equal to a plus n minus 1d. So for the sixth term, we can write a plus 6 minus 1d is equal to 30. So a plus 5d is equal to 30. So now we have to find S11, as the formula for finding the sum of nth term is equal to n by 2 2a plus n minus 1 d. So S11 will be equal to 11 by 2 2a plus 11 minus 1 d. So here S11 is equal to 2a plus 10 d. So here if we take 2 as common, comes a plus 5d. 2 and 2 will cancel. So the remaining equation is 11 into a plus 5d. As our a plus 5d we already calculated from the sixth term is 30, which is already given. So we can use that a plus 5d and we will put into this equation. So if we put a plus 5d in this equation, so S11 will be equal to 11 into 30, which is 330. So our final answer is S11 is equal to 330. Let's do one more example, so which is we have to find the sum of n terms of an AP whose kth term is 5k plus 1. So the solution is As the kth term is given as 5k plus 1, so we can write ak is equal to 5k plus 1. So we have to find the sum of n terms of an AP, which is Sn, and the formula for Sn is n by 2 into 2a plus n minus 1d. So here ak is equal to 5k plus 1. So we have to find our first term, second term and the common difference. So in order to find the first term, we can put k is equal to 1. So if we put k is equal to 1, our first term will be equal to 5 into 1 plus 1, which is equal to 6. Similarly, if we put k is equal to 2, we can find our second term, which is equal to 5 into 2 plus 1. So our second term will be equal to 5 into 2 is 10. 10 plus 1 is 11. So we have our first term and the second term. So we can easily find a common difference, which is d equal to a2 minus a1. So our a2 is 11, a1 is 6. So our common difference is equal to 5. So we can easily find our sum of the nth term, which is Sn is equal to n by 2 2a plus n minus 1 d. We don't have n, so the first term we already calculated, which is 6, n minus 1. The common difference also we calculated, which is 5, so is equal to n by 2 12 plus 5n minus 5, n by 2 12 minus 5 is equal to 7 plus 5n. So this is our final answer. Sn is equal to n by 2 into 7 plus 5n. Let's do one more example in which we have to find the sum of n terms, and our nth term is given as 5 minus 6n. So the solution of this problem is, so as our nth term is given as 5 minus 6n, so in order to find our sum of n terms, we have to find the first term and the common difference. So in order to find the first term, we can put n is equal to 1. So a1 is equal to 5 minus 6 into 1, which is equal to minus 1. a2 is equal to 5 minus 6 into 2, which is 5 minus 12, which is equal to minus 7. Similarly, we can find our third term by putting n is equal to 3 minus 6 into 3, 5 minus 18, which is equal to minus 13. So our arithmetic progression will be like minus 1 first term, minus 7 second term, minus 13 third term. So we can easily find our common difference. Common difference will be equal to a2 minus a1, which is minus 7 minus minus 1 minus 7 plus 1. So minus plus is minus, 7 minus 1 is 6, so final is minus 6. So our common difference is calculated as minus 6, and our first term is equal to minus 1. So we can easily find our sum of n terms. So Sn is equal to n by 2 2a plus n minus 1 d. We don't know the value of n. First term is equal to minus 1. The common difference we already calculated is minus 6. 2 into minus 1 is minus 2. So here minus 6 n minus 1 n by 2 minus 2 minus 6n. Minus 6 into minus 1 is plus 6. 6. So here 6 minus 2 is 4. 4 minus 6n. So if we take 2 as a common from this equation, so it becomes 2 minus 3n. So here 2 will cancel each other. So the final answer is n into 2 minus 3n. Let's do one more example, which is we have to find the sum of first 50 even numbers. So the solution is, so if we write the even numbers, we can write 2, 4, 6, 8. So this is our AP. So here the first term is equal to 2. Common difference is equal to A2 minus A1, which is 4 minus 2 is also equal to 2. And here we have to find the sum of first 50 even numbers. So it means the value of n is given, which is 50. So if we write the formula of the sum of n terms, it is n by 2 2a plus n minus 1 into d. So here the value of n is 50. The value of the first term is equal to 2. 50 minus 1. The common difference is also equal to 2. So as 2 into 25 is 50. 25. 2 into 2 is 4 plus 49 into 2. 25. 4 plus 49 into 2 is equal to 98. 25 into 102. 25 into 102 is equal to 2550. So our final answer is 2550. Let's do one more example, which is the sum of fourth and eighth term of an AP is given as 24, and the sum of sixth and 10th term of an AP is equal to 44, and we have to find the first three terms of the AP. So the solution is, as the sum of fourth and eighth term is given as 24, and the sum of sixth term and the 10th term is given as 44. As we know, the formula for nth term is given as a plus n minus 1 into d. So first we will find a4, which is a plus 4 minus 1 d. So a4 is equal to a plus 3d. Similarly, a8 will be equal to a plus 8 minus 1d. So the a8 will be equal to a plus 7d. Similarly, a6 will be equal to a plus 6 minus 1d. So a6 is equal to a plus 5d. And a10 will be equal to a plus 10 minus 1d. So a10 will be equal to a plus 9d. As the sum of fourth term and eighth term is given as 24, so we already find a4 and a8. a4 is equal to a plus 3d and a8 is equal to a plus 7d, which is 24. A plus a is 2a. 7d plus 3d is equal to 10d. So if we take 2 as a common, it becomes a plus 5d is equal to 24. So final equation is a plus 5d is equal to 24 by 2, which is 12. We name this as first equation. Similarly, the sum of sixth term and the 10th term is given as 44. So we already find out sixth term and the 10th term, which is a plus 5d plus a plus 9d. 44. A plus a is 2a. 9 plus 5 is 14. So we will take 2 as common. Becomes a plus 7d is equal to 44. So final equation is a plus 7d is equal to 44 by 2, which is 22. We will name this equation as second term. So now we will take both our equation which we named as 1 and 2. So our first equation was a plus 5d is equal to 12, and our second equation was a plus 7d is equal to 22. So we will solve both these equation by the elimination method. So if we subtract both these equations, 1 minus 2, so it will become a plus 5d minus a minus 7d is equal to 12. minus 22. So here a minus a is 0. 5d minus 7d is equal to minus 2d. 12 minus 22 is minus 10. So our d is equal to 5. So we will put d is equal to 5 in any of the equation. So we will put d is equal to 5 in the first equation, which is a plus 5d is equal to 12. The value of d we calculated is 5. So the value of a is 12 minus 25, which is minus 13. So we find our first term, which is minus 13. We already find our common difference, which is 5. So as we know, the value of d is equal to a2 minus a1. D we already find out, which is 5, and the value of a1 is minus 13. So a2 plus 13. So the value of second term is equal to 5 minus 13, which is equal to minus 8. So we find out our first two terms, which is a1 is equal to minus 13 and a2 is equal to minus 8. So in order to find the third term, we can use the formula a plus n minus 1d, a plus 3 minus 1d. So here the first term is equal to minus 13. To d we already find out, which is 5 minus 13 plus 10. So our third term is equal to minus 3. So we can write our arithmetic progression as minus 13 minus 8 minus 3. Let's do one more example in which we have to show that sum of m plus nth term and m minus nth term of an AP is equal to twice the mth term. So the solution of this problem is, so as we know, the formula for the nth term is equal to a plus n minus 1d. So for the m plus nth term, it will be a m plus n m plus n minus 1 into d. Similarly, for the m minus nth term, it will be a plus m minus n minus 1 into d. Similarly, for the mth term, it will be equal to a plus m minus 1 into d. So we have to prove that a m plus n plus a m minus nth term is equal to twice the mth term. This thing we have to prove. So first we will add first two terms. So a plus m plus n minus 1d plus a plus m minus n minus 1 into d. So a plus a is 2a plus, and if we take d as a common in these two terms, so it will be equal to m plus n minus 1 plus m minus n minus 1. So here 2a plus d. So m plus m is equal to 2m. N minus n is 0. And minus 1 is minus 2. So if we take 2 as a common, m minus 1. So here if we take 2 from the whole equation as a common, will equal to a plus m minus 1 into d. So as our mth term is equal to a plus m minus 1d, so it has been proved that the sum of m plus nth term and m minus nth term is twice the mth term.